All right, Algebra 1A students, welcome to part 1 of your video on lesson 5-7. In this video, we're going to be talking about scatter plots, what they look like and how they can relate to linear equations. So a scatter plot is basically a graph of a real-world set of data that we can plot as coordinate points. Right, so it's basically a graph that relates two sets of numbers by plotting them on a graph. Okay, and we can kind of see if the numbers are going up or if they're going down or if they're just randomly scattered and so on. Okay, a lot of times our graphs will not be like this anymore, where we had the 4 quadrants with the positives and negatives, because a lot of times we'll only have positive numbers, but certainly if we have positives and negatives, we do still need to use this kind of graph. Okay. So if we look at a couple examples here, this is a scatter plot, this is another scatter plot, and this is a different scatter plot where they have points kind of scattered throughout them. That's what a scatter plot means. And if we see the y values and the x values both increasing as we look at our scatter plot, our x's are increasing and our y's are increasing, that scatter plot is said to have what's called a positive correlation. So it's positive when y increases and x increases. Okay? When we see the y values decreasing or going down as our x values are going up, like in this scatter plot here, our x values are going up, but our y's are coming down like this. This scatter plot is said to have a negative correlation. Okay, a negative correlation. And then if the x and y really, like, you can't really see a pattern anywhere, like there's just a bunch of randomly scattered points every which way, like polka dots on your summer dress or something like that, we just say that scatter plot has no correlation at all. No correlation at all. Okay? So positive, negative, no correlation basically is telling us how are these two different sets of data related. Do they increase with each other? Does one of them go down? Are they totally random? Okay, that's called the correlation, correlation, of the two sets of data. Okay? So part of what we're asked to do is make a scatter plot and describe the correlation that we see. Okay? So what I want to do is I want to look at this table of data and create a scatter plot. All right? So here I have altitudes and I have temperatures. And I've made a scatter plot here of temperatures on my y-axis and altitude on my x-axis. Usually we put the top one will be x and then the bottom one will be y. And what I'm going to do is just create a scatter plot of this. I'll make my dots a little bit bigger here. So the first one I see is altitude of 0, which would be way back here. Temperature of 59 degrees, which is right about there, I suppose. Right? If I go up to 500, let's see, 1, 2, 3, 4, 5,000. So 500 would be here, halfway between 0 and 1,000. I'm up at 59.2 degrees, which is pretty much exactly the same spot as I was before. If I go out to 1,000 feet up, I'm actually up at 61, which is a little bit higher than I was before. And then I go out to 1,500 in the altitude, and I have to graph 1,500 with 55.5, which is going to be a little bit lower now, like that. And then when I get to 2,000, I am at 41.6. Should be right about there. If I'm at 2,500, I'm down at 29.8, which is right about there. Out at 3,000, I'm at 29.9, which should be pretty much identical to that one. 3,500, I'm just below 20, which I guess would be right about there. If I'm at 4,500, I'm at 12.4, which is going to be a little bit lower. And then out at 5,000, oops, did I skip one? Yeah, I did. Oh yeah, 4,000, I actually go back up, don't I? I do.
Roger, if you're still in the building, please call extension 504. Thank you.
So at 4,000, I should actually be back up here at 26. And then out at 4,500, I'm down at 12. And then at 5,000, I'm at 0.6, which is basically 0 degrees. So I've just created a scatter plot of a bunch of points that came from my two sets of data about altitude and temperature. And now I would be asked in the homework problem to describe the correlation of this set of data. Well, the correlation here is pretty clearly negative. Correlation is negative, right? And that's all I really need to say. Correlation is negative. Because as my x values increase, as my altitudes go up, what's happening to my temperature? Temperature is going down. Okay, so that would be a negative correlation. All right? So that's part of your homework. The other part of your homework deals with something called a trend line. So sometimes when we have a scatter plot, to see the relationship a little bit more clearly or to see the correlation better, we draw what's called a trend line. And a trend line is just a line on a scatter plot that we draw near the points that shows the correlation. So we just try to draw as nice a line as we can, kind of through the middle of where the points are going. So for example, in my altitude example, I might go maybe through this point and kind of do something like this. I'd like it to be a straight line, of course, so maybe I'll do something more like that. Something like that would be my trend line. Okay, and this trend line just helps me see what the correlation is. Clearly, this line has a negative slope. In fact, I could figure out what the slope was if I just estimate where this value is. Maybe that's at, what do we think? That could be about 63 degrees. So if that's at about 63 degrees, and then down here is at 0 degrees, I think my rise is a negative 63, which would be the top number of my slope fraction, right? Slope is easy and fun as long as I remember rise over run. Negative 63 over, and then where do I think this one ended up? Let's see, that was 1,000, 2,000, 3,000, 4,000, maybe 4,500 is where I hit down there. Maybe a little bit past there, 4,600 maybe. So I put that under here, 4,600, and I have created a slope fraction that I could reduce if I wanted to, but I don't really feel like it. So this slope right here, because it's negative, shows me that this is a negative correlation, right? And I should be able to see that my y-intercept value, where I'm crossing this x or y-axis up here, is at this 63 value. So now it feels like I can write an equation for this trend line, because I know the slope and I know my y-intercept. So I should write my equation in slope-intercept form, where I have y equals mx plus my y-intercept value, and of course my m is just all of this. So if I scale that down and slide that in there, this equation would represent that trend line. And now that was just my best guess of what the trend line is. I can't say for sure that that's exactly what it should be, but this equation then could help me find a whole bunch more points, right? And when we use the equation that we're writing to estimate other point values that we don't necessarily have on our scatter plot, we're either doing what's called interpolation or extrapolation, and I need to talk about that here before we end this video. So as it says here, we can use a trend line to estimate a value between some of the data values we know. Right? So if I just pause for a second and go back up here, like let's say for example I wanted to know what the temperature would be if I was 250 meters above sea level or above the ground, right? That would be in between these two numbers here, between 0 and 500. So I could use my trend line to estimate that value by just putting the 250 that I want in for x, and then it spits out my y value for me. That's called interpolation. Inter means between. So if you're estimating a value between two known values, you're doing interpolation. And extrapolation, extra means outside. Extra is predicting a value outside the range of known values. Generally speaking, just generally speaking, extrapolation is bad. We don't want to do extrapolation, okay? If you want to hear a funny example of why we don't do extrapolation, ask me about that in class tomorrow. But general rule, as our general rule, extrapolation is bad, not something we want to do. Interpolation, very much okay. We should be planning to do that using our trend line equation to estimate other values. But extrapolation in general is bad and dangerous. Don't do that, please. Okay? Extrapolation obviously going way outside of the known values. I know that was a lot of information in this video. If you have any questions about anything, make sure you make a note to ask me in class tomorrow. But otherwise, that's all I have for you. Have a wonderful night.